Today we will discuss chapter number 3, logic gates and logic circuits. That is, the remaining gates were NAND gate, NOR gate and XOR gate, or the exclusive OR gate. NAND gate, which is also known as NOT AND. The symbol of NAND gate is similar to AND gate, only there is a NOT over there. Both of the inputs with A and B, and the output is X. So the logic notation for NAND gate is X is equal to A NAND B, and the Boolean algebraic notation for NAND gate is X is equal to A dot B whole bar. If we take it as A dot B, then it is a AND gate. So the truth table for NAND gate is both of the inputs with A and B and the output X. So first of all, we will consider that input A is 0 and B is 0. While placing the values in Boolean algebraic notation, A is 0 and B is also 0. So something multiplied by 0 is 0. 0 bar is equal to 1. So the answer is 1. When we take input A is 0 and B is 1, 0 multiplied by 1, that is 0. 0 bar is equal to 1. Similar to that, the other remaining values are. So the Boolean algebraic notation for AND gate was X is equal to A dot B. When we place a whole bar or a complete bar on the values of A dot B, then it will become a NAND gate. The second one is NOR gate, which is also known as NOT OR. The symbol of NOR gate is almost similar to OR gate, only there is a NOT over there, while the remaining diagram is the same. So the logic notation for NOR gate is X is equal to A NOR B, whereas Boolean algebraic notation for NOR gate is X is equal to A plus B whole bar. So the truth table for NOR gate is input, that is A and B, and the output is X. So A and B, the values of A and B are this. First of all, by taking the input 0, the value of A is 0 and B is also 0, so 0 plus 0, that is 0, and the bar over there will reverse its value, so opposite of 0 is 1. So the first output is 1. Now the second one, if the value of A is 0 and the value of B is 1, 0 plus 1, that is 1. 1 bar is 0, opposite of 1 is 0. So the output will be 0. The Boolean algebraic notation for OR gate was X is equal to A plus B. When we will place a bar over A plus B, then it will become a NOR gate. The third one was XOR gate, or the XOR gate, that is exclusive OR gate. The logic notation of XOR gate is X is equal to A XOR B, and the Boolean algebraic notation is X is equal to A dot B bar plus A bar dot B. So the input is A, B, and the output X. that is 0 0 1 1 0 1 0 1. So by taking the first value, that is the value of a is 0 and the value of b is 0. So first of all, the value of a is 0, value of b is 0, dot value of b is 0 plus a 0 dot b 0. There is a bar over there, so this. So when we solve it further, that is a dot 0 bar is 1 plus 0 bar is 1 dot 0. Something multiplied by 0 is 0 plus something multiplied by 0 is 0. That will be the 0. So our first output is 0. Now the second one is the value of a is 0. Okay, first of all, write the Boolean algebraic notation over here. A dot b bar plus a bar dot b. So value of a is 0 and the b is 1 dot 1 bar plus value of a is 0 plus b dot b. So 0 multiplied by 1 bar, that will be 1 bar is 0 plus 0 bar is 1 dot 1. So when we multiply by 0 that is 0 plus 1 multiplied by 1 is 1. So 0 plus 1 is 1. The output of second combination is 1. Similar to that, when we will solve the third one and the fourth one, their output will be 1 and 0. So from the truth table, we can assume that when the values of inputs are same, that is a is 0 and b is 0, the output will be 0. Or when the value of a is 1 and b is 1, the value will be 0. When there are two different input values, then the output is 1. That is if a is 0 and b is 1, or if a is 1 and b is 0, then the output will be 1. Now I am giving you a practice question. You have to prove that both of the expressions have the same value. So for your practices, find out why x is equal to a dot b bar plus a bar dot b and a plus b dot a dot b complete bar. Both of these expressions represents the same logic gate. That is your practice question.